this is Dr. Sridhar, back to you with another video lecture on one of the important electrical network theorem, that is nothing but the superposition principle, or sometimes this is also called as the superposition theorem. This is very important in electrical engineering, not only in electrical, in associated electrical related branches like ECE or EEE students or faculty. This is very important to know the response in any electrical network or in electronic networks. The condition here, because already now in our previous videos we have discussed about Thevenin's theorem, Norton's theorem, and other network theorems elaborately. But what is the uniqueness this superposition principle is having? So generally people will be confused if we could see more number of energy sources in the electrical network. And here, if only one electrical energy source, either voltage or current is there, then we feel that it is very simple. We can play with the circuit, and at any point we can find out the response. It means response is nothing but the output. Either the output may be voltage or current. But if instead of one electrical energy source, if we are going for 2 or 3 or 4 like that, then people will feel some inconvenient in solving the problem, because if more number of energy sources comes into picture, now it is a time consuming process, and moreover it is a laborious process to know the response in the electrical network at any instant of time or at any point in the electrical network. So in order to overcome these difficulties, this superposition principle highly helpful for us. So what is this superposition principle? In what way we are going to reduce that electrical network to find out the response at any point? Now this, in today's video session, we are going to discuss about superposition principle with some suitable examples. See, in broad sense, the superposition principle or superposition theorem can be say that the response. Now response is nothing but, what do you mean by response? Response is nothing but output, and cause is nothing but input. So input output, just like cause and response. So if you are giving any voltage or current as an input to any passive element or any electrical component, then definitely you can see the response. So input, if you are giving as a energy source or energy input to that electrical component, then definitely electrical element will react according to the input, and it will exhibit its own response. So the response is nothing but, again, it may be a voltage or current. Here the thing here it is, the input in the electrical systems, that input either it may be a voltage or current, output is also either voltage or current. So in the broad sense, what is this superposition principle means? The response, current or voltage in a linear network at any point due to multiple sources. That multiple sources could be either voltages or currents, including linear dependent sources or independent sources, whatever it may be, can be calculated by summing the effects of each source considered separately. Here, what is this summing the effects of each source considered separately? Suppose if you are taking one simple electrical network, this is R1, this may be one voltage source V1, and here this is suppose R2, and this is R3. Now this is one more voltage source. Here this is R5. Let me assume this is some current source. This is I2. Let me assume. So now this is V2 voltage, and this is the V1 voltage. Here this circuit is, if you could keenly observe here, the circuit is consisting of 4 resistors R1, R2, R3, R4, and 2 voltages V1, V2, and I1. So now problem is, I want to see the response in the R2, whatever the IR2 current. So what is this value? How can we do this? Now in such cases, now see here only one important thumb rule here it is, which theorem you have to apply to see the response or to find out the response across any element or through that particular element. How can we do that? Now in such cases, Now you have to go for number of energy source. If more number of energy sources are there, then the superposition theorem is the best solution to know the responses at any point in the electrical network. Now see here, now with the help of the superposition principle, how can you find out the response through this R2? So what about the how much of IR2 current is there? So here there are three voltage sources are there, V1, V2 and current source I. Now multiple number of sources. So there are multiple number of sources are there, 1, 2 and 3. See, in this superposition principle, out of these available number of sources, you have to active one source at a time. Suppose let me active V1 as active. Now what about the V2 and current source? Let me make this as an inactive. So we will see how can we make active, how can we see inactive means. Active means that will be connected to the electrical network. And inactive in the sense, suppose inactive means, what do you mean by inactive? Inactive is now any voltage source. Suppose if you are taking this is the V2 voltage source. Inactive in the sense, this contribution of this voltage source must and should be 0 volts. Now the contribution of this second voltage source must and should be 0. It means 0 volts means when you can see the 0 volts response. Now if the voltage source is short circuited by itself, now that's contribution in the network is 0. So means indirectly all the voltage sources should be represented with its internal resistance. Now ideally if you are speaking, the internal resistance of this voltage source is 0. That's what the contribution of this voltage source is 0. Like this, the voltage sources can be made inoperative or inactive. So that is nothing but the turning off of that voltage sources. Either based on your convenience, you can give any name. Now turning off of that voltage source means the contribution of that particular voltage source must and should be 0 in the electrical network. Now for that particular instant, now here we are taking if V1 is active and we are assuming V2 and current source as inactive. Now the problem here it is, how can we make inactive? Now how can we make inactive means the voltage source should be represented with its internal resistance. So that is nothing but the voltage source's internal resistance in ideal condition, that is 0. Means indirectly the voltage sources should be short circuited. That is the important point. And next one is current source. How can we make the current source as inactive? Now this is the current source. Now the contribution of this current should be 0. Inactive in the sense, just like the voltage source, inactive means the contribution of this current source must be 0 amps. Now if it is 0 amps means when we can see 0 amps of current. Now if any conductor breaks down, if any conductor breaks into pieces, then only we can see the current is 0. It means indirectly you have to see or you have to convert current sources to open circuiting condition. Just like voltage sources, we have short circuited. Current sources, it must be open circuited. Like this, we are going to make the remaining energy sources in the electrical network. If one electrical energy source is active, then you have to convert the remaining electrical energy sources as inactive. So this is current source can be turned to off by open circuiting its terminal. That is nothing but again, ideally if you are speaking, whatever the internal impedance of this current source, that is nothing but the infinity. So that is nothing but the indirectly open circuiting the cases. So how can we turn off? How can we make inoperative? How can we make inactive sources? Means the voltage sources, how many number of voltage sources are there? That many number of voltage sources should be represented with the short circuiting by itself, and current sources are replaced with its internal resistance, that is nothing but the open circuiting. So like this, we are going to make unnecessary voltage sources, not exactly unnecessary, I am sorry, that the remaining voltage sources or remaining current sources, except the active source, you have to make inactive. This is the method how that energy sources can be turned off or inactive or make inoperative. So here, now if V1 is only active, then the remaining sources means what happens, V2 will be short circuited by itself, and this is nothing but the open circuited by itself. Then V1 will drive some current. So let me assume the response is nothing but the I1. Similarly, second case is nothing but the only V2 is active, V1 comma I1 is nothing but it is inactive. I mean not I1. So this may be because of, let me assume IV1. So I1 source and V1 voltage source are inactive. So in that cases, what happens? This becomes short circuiting. This is active, and this is nothing but open circuit. In that cases, what happens? This voltage source may drive its own current. That current through this resistance is nothing but the IV2. And in the third case, what happens? Only current source is active. V1 voltage source and V2 voltage sources are nothing but the inactive. So only this current, definitely it will drive some amount of current through this R2 because this is short circuiting and this is short circuiting. In that cases, what happens? That current may be because of I1 source. This is only if I1. So how many responses we have calculated? Now if V1 is active, now the current flowing through this R2 resistance is nothing but IV1 current. And if V2 is active, how much of current it is flowing? IV2. And if only I1 is active, how much of current is flowing through this R2 resistance? That is nothing but the II1. So this single resistor, this particular single resistor is having three responses. So one response is nothing but the IV1. Now this is because if V1 voltage source is active and remaining energy sources are inactive. And second response is nothing but the IV2. That is only second energy source, that is second voltage source is active. V1 voltage source and current source is inactive. And third one is nothing but, third response is II1. This is because of only if the current source is active, remaining voltage sources are inactive. So the response, now coming, just to go back to the statement, can be calculated by summing the effects of each source considered separately. So we have considered the response separately by taking separate energy source. So IV1 plus IV2 plus I1. And then finally what happens? The total response at any point, due to multiple sources can be calculated by summing up. So IV1 plus IV2 plus II1 is nothing but finally resultant current through R2 resistance. This is what the superposition principle is telling to us. So this is very simple because you need not work out with n number of energy sources at a time. So in this superposition principle, at that particular instant, at a time, you are permitted to work with only one energy source. You can make the remaining number of energy sources in the electrical system as inactive. So you have to calculate this response separately, and then finally you have to sum all these responses together. Then finally the resultant value is the final response through that particular point or at that particular point. So this is the superposition principle is explaining. So all the sources, just now also we have discussed, all the sources are turned off. All the sources in the sense except active source. So with which you want to see the response at that particular point in the electrical circuit, that source is active and remaining sources are inactive. So that inactive sources must and should be turned off. Just now also we have discussed about this. And how can we turn off the energy sources? Now the voltage sources should be represented as a short circuiting and current sources should be represented as a open circuiting conditions. This is the way we are going to use to turn off the remaining active energy sources except the energy source due to which we want to see the response at any point in the electrical circuit. And more clearly, what is the statement here? Just now also we have discussed the outline we have discussed, and more exactly what is the statement of the superposition theorem? That is, it states that in any linear bilateral active network having more than one energy source, the response across any element or at any point is the sum of the responses obtained from each source considered separately, and all other sources are replaced by their internal resistance. The superposition is highly helpful if the electrical system is having more number of energy sources. Now this is a statement of the superposition theorem. And let me take one simple example. Now with this example, let me find out the responses and the effectiveness of this superposition principle in calculating the responses at or through any element. Now here in this system, in this simple electrical network, there are two energy sources, out of which one is voltage source and one is current source, and there are three resistances are there. Now, let me find out what is the response through this R3 that is marked in green color in the electrical network. So, these R3 are the current through this R3, which is nothing but designated as I, that will be contributed by Vs energy source, that is Vs voltage source, and Is source current. Now, suppose if only Vs is active, if first Vs is active, then you have to make that current source as inactive. How can we turn off this current source here? The current sources shall be turned off by open circuiting its terminals. That is nothing but that is a way of replacing the current source with its internal resistance. So, this is nothing but Is is simply open circuited. Now, here in this second circuit, how many number of energy sources are there? Only one energy source, that is nothing but Vs is the one voltage source is active, and Is is nothing but that is the current source which is inactive here. So, that is nothing but we have turned off that current source. Only that voltage source is active. Then the response of this Vs is nothing but, let me assume as I1, because our interest is find out the response, that is nothing but the current through that resistor R3. So, because of this Vs, the current is nothing but I1. Because only one energy source is active, we have assumed this. So, if Vs is only active, then the current through this R3 resistor is nothing but I1, and Is is anyhow this is inactive. The contribution of this Is is 0 here. So, that's why only Vs is active, then its response through this R3 is I1. And finally, so one more energy source. Now, in the third case, now I am going to take only Is is active, only current source is active, and the voltage source is nothing but the inactive. So, if it is inactive, then what is that source here? Voltage source. So, voltage source must and should be short circuited by itself, and only current source is acting. So, you have to find out the response because of the source current, which is nothing but I2. So, like this, now if I1 is I2 are known to us, then finally the total response I, which was marked in the figure 1, that is nothing but the sum of the response because of first energy source plus the response because of the second energy source. That is I is equal to I1 plus I2. So, I hope you have followed this superposition theorem and superposition principle. And in this video, we have given good examples, and we have given clear explanation about making the sources active and making the sources inactive. And hopefully you might have enjoyed this video session. Thank you very much. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.